Hi all, welcome back to yet another exciting blog and a video demonstration in the EKS Anywhere Saga series. And this time around, we will look at the ubiquitous way of GitOps, since it's the pervasive way of deploying applications on EKS Anywhere clusters. We will look at that method to deploy the CSI drivers for Dell PowerScale. Now, the interesting fact remains is that, while customers and enterprises, they build their pipelines, the expectations is that along with the application rollouts, the key components towards the infrastructure are also rolled out as a part of the pipeline. In this particular case, in the last video, you would have seen that we had rendered an EKS Anywhere cluster based on Flux version 2, which has a native integration with EKS Anywhere. And we did demonstrate to you how a GitOps enabled cluster can be created, and then how we can manage the cluster and things like that. In this particular case, we will do a similar bootstrapping of a cluster with GitOps toolkit, and thereafter, we will deploy the CSI drivers for Dell PowerScale and also follow it up with a GitOps deployment of a BusyBox application, which consumes the persistent volumes from Dell PowerScale. So this becomes like an end-to-end experience where you have the infrastructure components or the cluster, the infrastructure components, that's the CSI driver, and a demo application which actually uses this particular infrastructure, right? So let's move ahead and let me share my screen, starting with the fact that Dell already has or supports number of ways that we can actually deploy the CSI drivers, right? In this case, we are looking at the Helm charts repository for Dell, and it includes support for all the prominent platforms that Dell has. Isilon in this case, which is also called as PowerScale, that we will be using. Other than that, you have PowerMax, PowerStore, and others, right? So we are looking at CSI Isilon. So the question is, we can go ahead and deploy it through a Helm chart, as in a regular Helm command, or in the GitOps construct, we will be looking at the GitOps controller to do a referencing of this particular Helm chart. Now, before we start, let me spell out, I won't say a caveat per se, but if you look at this chart.yaml, the semantic versioning for the chart expects that on the cluster, your Kubernetes version follows a standard semantic versioning, which is in this format. And you can see that, if we use a complex versioning like something like this, we need to replace this particular value in the chart.yaml. Now, our EKS Anywhere clusters, and I'll show it to you in the practical demonstration, follows something similar, which is a non-standard way of looking at the semantics in that sense, right? So it's incompatible. So to start with, we will be cloning this particular repo, which is the Dell Helm charts, into a private, privately hosted GitLab. So we will create a repository and clone this particular repo, and thereby we will have the ability to do this particular replacement of this value and host this particular repo locally. Unfortunately, there is no way to override this through a Helm values. So we will have to clone this particular repo into a local GitLab. So that's the first thing. Now, second, let me also show you this entire set of procedure. We will just walk through this very quickly, and we will execute this procedure so that you have a reference point to work with in case you decide to experiment it. Just for convenience, we start exporting some of the known variables. Okay, you could name it anything, but just make sure that those variables are referenced here. You change the values accordingly. Now, this is just to kind of ensure that when we are working with GitLabs and repos and things like that, we don't fall prey to copy paste commands and all that. So I'm exporting my PowerScale password here. Okay, the directory path for the EKS Anywhere cluster in the admin machine. Okay, so generally I keep it as /$home and $cluster name. you could have a different directory path, right? Depending upon how you have set up the admin node on your EKS for your EKS Anywhere setup. My GitLab host is gitlab3.poc, thecloudgarage.com. It's running on a web port of 10443. The SSH port is 224 The user slug under which the repos will be created is /root. The repository that I will be using in the GitLab for hosting my GitOps committed configuration for the EKS Anywhere cluster. You know that when the cluster gets created, the Flux configurations and the cluster configurations are committed to a GitOps repo, right, as a part of the GitOps pipeline. So that repository is called as GitOps-demo. It's practically an empty to start with, an empty repository, but it's a private repository. So it also has a associated personal access token. Likewise, like I said, we will be cloning this particular repo of Dell Helm charts. So I have created another empty repository, which is called as Dell-Helm-charts. This is a public repository. Note that we are not going to store any sensitive or confidential information. So this can be, it's locally hosted, but it's a public repository. But to commit files to it, we've also given it a personal access token to ensure that, the commits are done in terms of the cloning effect. Now we'll just kind of start removing any previous artifacts so that we don't fall prey to any of the previous installations. Now the first steps here take care of cloning the branch 2.10.0. This is the version of the CSI drivers that we will install. You could have a different version that you could be working with. So just select your branch that you want to clone from the Dell Helm charts, right? So once we cloned it locally, we will just, do this particular command of a replacement of that cube version. And instead of this being greater than equal to 1.2.1.21.0, we will keep it as greater than or equal to 121.0R0. And this is a good format actually to ensure that any kind of, non-standard semantics or, anything that is actually different to the standard semantics can be accommodated. So just go ahead. If you are working with a higher Kubernetes version, which I doubt, but you could increase this value as well, right? So we will just do this replacement in the locally cloned repo and then commit these to, the Dell Helm charts repository on my GitLab with a branch name called as Dell Helm charts -2.10.0. Okay. So this is what we will do. Once we have done this, so let's start with this itself. Note that due to the nature of the sensitivity for the credentials, I've already exported this in my terminal, so I won't be doing this again. I will start with this exports. So let's do this. Okay, and you could, before we start, so these are the two repos which I have set up. You can see that these are completely blank as such. Okay, this is the GitOps demo, which the cluster files will be stored in, and some of the other infrastructure components which will make a part of the pipeline will be stored in, right? The second repo is the Dell Helm charts, which is empty as of now. Okay, and we will create a local clone and commit into this. So this is the GitLab. It's GitLab 3 POC, whatever, right? So you get it. So let's go on to my admin machine here. Okay, I have already done the removal of previous any artifacts, but let's do that again. So let me just quickly export all the variables here. So the variables are exported. Let me do this once again in case. Okay. Now, since we've done this removal of previous artifacts, now we will start a quick sequence of commands to ensure that we can clone the Dell charts and push it to our upstream which is the local repo for storing these. Okay, so this is done. Let's quickly observe if these files are committed. So I'll go to Dell Helm charts. We have created a new branch here. You can see this Dell Helm charts 210. And we can see all the files are here. Particularly, I'm interested in the CSI isilon chart.yaml. And we can see that the cube version has been changed from, from the standard semantic to this value. Okay, so this is good actually. Now, next, what we will do is we will create a YAML file, which will have so if you work with the CSI drivers for PowerScale, if you have any experience in the past, you will know that we need a PowerScale credentials file, which should include the cluster name. This is the PowerScale cluster, the username and the password and the endpoint and whatever, right? Now in this case, I've just kind of given a dollar value for the password so that once we cat this particular file, the content will be automatically done here. So let me create this particular file. Here this first. So this is an unencrypted file as such. Now we won't be directly committing this particular secret to the GitOps repo because of the sensitivity when you are doing GitOps. Obviously, although it's a private repo and things like that, but it could be shared eventually and it could end up in being, compromised in more than one ways, right? So we won't be basically committing this particular file directly as such. We will be using Mozilla socks plus age to encrypt this particular secret and then storing it in the GitOps repo. So we'll see all of that right now. Let's create this particular file as such. Okay. I have already installed Mozilla socks and age, so not a problem there. We don't have to reinstall this particular thing. So what we will do now is to just create. Okay, so before we do this, let's create the cluster as such, the EKS Anywhere cluster, and then we will progress from there on to build the remaining structure of the repo or for the repo commit and all that. So let's create the EKS Anywhere cluster. I am on the admin terminal, and if I look into the cluster.yaml, my cluster is going to be called EKS-A-GitOps-01. The GitOps reference is my Flux config, which has the configuration block towards the end. And if you have seen the previous blog and video associated with GitOps clusters, you will see what I mean by this, right? But the repository URL, you can see that it's going to be GitLab 3 POC Cloud Garage 2224, the SSH port. The user slug is /root gitops-demo.git. Okay. So indeed, when we create this, the name of the repo as seen in GitLab is going to be gitops-demo. But when you see the Git repository as defined by Flux in its own CRD, it's called as Flux-main. So don't get confused there. Flux-main is the local Flux, how it references it. That's the default way it creates the name. Flux-main Git repository in the Flux construct will refer to this particular GitOps-demo, GitLab repo. So let's go ahead and create the cluster, EKSCTL anywhere, create, okay, let me clear first. EKSCTL anywhere, create cluster -f cluster.yaml. Okay. So the cluster will take about 15-20 minutes to get created. Interestingly, and I've mentioned this in the previous video as well. If you have a problem with the repository or the Flux configuration or the SSH keys or whatever, it'll just kind of time out, or it'll basically opt out during the validation phase itself, right? So we've gone ahead, we've started the process, means everything is good right now. Let me pause and then resume once the cluster is fully created, and then we will do the observations further. Okay. Okay, so we can see that the cluster has been created, right? And as a part of the cluster creation, you should also see the commits have been finalized and committed to the GitOps repository. Along with that, we should also see installing GitOps toolkit on the workload cluster, right? So the Flux components will be installed on the cluster. The cluster configuration files, along with the GitOps configuration toolkit and the Flux components, are also committed onto the GitOps repository associated with this cluster, right? So let's just go and verify that part. Okay, so we were here. Let's go back and see what things have popped into our GitOps demo repo. So we can see the structure here, clusters / EKSA GitOps 01. That's the name of the cluster. So you have, in our case, this is a standalone workload cluster. So the management cluster name and the workload cluster name is the same. It's a standalone workload cluster. So clusters, the management cluster name. And then inside of that, you have, basically you can see, right, clusters. This is the cluster, and EKSA GitOps. This is the workload cluster name and EKSA system, right? Inside of that, so you can see management cluster name, the workload cluster name, both being the same because of the standalone workload cluster. Inside of that, EKSA-system, and you have the cluster configuration file, right? So this is pretty much should be known to you if you've seen the previous video. And if we do any changes to the cluster configuration, scaling, upgrades, those will be reflected in the cluster as well, right? But that's not the intent and the emphasis of this demo. Now we've got a structure of our GitOps where the Flux Flux components also are installed. So the Flux systems are here. And what Flux controller will do is, under this particular directory, okay, namely this one, yeah, under this cluster. Yeah. If there is any new file that pops in, okay, then it would be actually tracked to, be deployed in the cluster, right? So right now, our CSI PowerScale drivers, nothing is committed, the files, nothing has been committed to the GitOps repo. Once we commit those files, okay, and I'll show you what the file structure looks like, what files have to be committed and all that. But once we commit those files, they will be rolled out as part of the deployment as a pipeline to our target cluster. So let's revisit basically what all files do we need to commit into this particular cluster repo. Let's go back to our documentation here. So starting with, like I said, that we have created a plain YAML for our PowerScale secret or the password and credentials, but we don't intend to put this file directly into the GitOps repo. So we would be using SOPSNH to encrypt this file, okay, starting with creating a age key, okay, and then we will have to derive the value of the public key and then create a creation rules. I think if you worked with SOPs, you would know what this means, but specifically targeting the YAML files that we need to encrypt, and inside of that YAML, the string data that could be observed, and then the public key value, right? So here we are actually referencing the public key as a variable, and then we are passing that variable here in that file. Now, once we do this particular thing, we will create a template, a generic secret. We will not deploy this particular secret to the cluster, but we are just creating so we are saying kubectl create secret generic isilon creds namespace CSI PowerScale from file. This is the file, okay, from file, and output as YAML, and we are doing a dry run, and then putting that content of the secret into So it's basically going to be a base 64 encoded value of this particular file content, right, into a new file called a CSI PowerScale creds, let's say encrypted. It's not encrypted yet, but we will do that as a placeholder, right? So we'll create this particular file. And then since now we have the age private key and the public key, we will use basically SOPs to encrypt in place this particular file that has been created as a dry run. Okay. And this particular file will then, have or bear the contents or the encrypted contents of this secret as such, right? Okay, which is the base 64 encoded value of this file. So let's do this. I've already installed SOPs in Age. So let's do this step first. It may seem like an overhead, but this is required because, GitOps, when you, again, the pathway is GitOps. And if it's GitOps, then secrets need to be encrypted, right? So I'm not going to debate and as to why and things like that, but this is required. Okay, so let's take this particular set of commands. We will go onto my terminal. The cluster is already created. Let's just first set my kubectl context. My cluster name is EKS-A GitOps-01, EKS-A GitOps-01. So this is just a handy script that I use to switch the kubectl context. I should now have access to the cluster. So you can see the reason we were talking about, cloning the Dell Helm repository and then making that kube version changes because the semantic, versioning is slightly complicated, more complex as opposed to a standard semantic version. I'm not gonna call out why AWS goes or follows this particular pattern, but this is what it is, right? And that's the reason we did all that hoopla of cloning and then changing the kube version and maintaining a local repo of that. Now we are able to communicate with our cluster. So we will do the encryption of our, sorry, let me take this set of commands again from here. And then we will create the encrypted value of, okay, so the public key is known. This is the public key. Now from here on, since this private and public key pair is created, you might as well, so this private key is very important. We should not be sharing this private key with anybody. You might as well throw it and lock it or whatever, you can do. Whenever you want to now create an encrypted value, a new encrypted value, all you have to do is actually use this key to encrypt. For the decryption part, you have the private key, right? So store it in a safe place. Now that we have this, let's just cat the CSI PowerScale creds encrypted. So you can see that, the whole YAML, initially the secret, the base 64 encoded secret of the YAML is now stored as a encrypted file. Okay, so this is good. Now, next, what we will do is we will have to, for Flux, the way Flux works is the customization controller, when we put this encrypted secret of the PowerScale in GitOps, and it basically tries to deploy and create a secret from it actually in the cluster for use by the drivers, it has to decrypt it and store it. But that decryption only can be done by Flux controller customization based on the private key. Okay, so we will have to create that particular private key in the namespace Flux system. So all we need to do is to ensure that there is no unauthorized access to this Flux system namespace and that it is not compromised, right? Because it holds your private key that may be used for other secrets as well. But in this case, we are using it for the PowerScale credentials, right? So we will take the value of this age key, private key, and create a secret with this in the cluster. So let's do that. Okay, so our private key is created now. Next, we will now build the file structure. Now, I could have simply, stored these files somewhere and then, cloned them and just uploaded. But we will go through the nuance of this because, every GitOps project is unique in a way. And it all depends upon how you organize your GitOps project, right? The way I've organized this is that this is the GitOps repo, the GitOps hyphen demo. Under that, you have apps. Right now, we just have clusters. And, just for a nomenclature sake, I've mentioned it as the management cluster name and the workload cluster name. So we saw this workload cluster name, and under that, we had the cluster configuration file under EKS system and the Flux system, right? And the Flux components. Outside of these two, so under the management cluster name itself, we will create these two files, two customization controllers. One is specific to the CSI PowerScale deployment, and I'll talk about these customization controllers in a while. The second is a BusyBox customization control. So inside the customization controller, what you're saying is a reference. So this customization controller is looked upon by Flux to say that what and from where I need to fetch, let's say, a Helm chart. Okay. So in that, we will specify in this customization controller the Git repository, okay, from where this particular templates or the, not the final templates of the Helm, but the references to the Git repository and the Helm chart are to be fetched. And then once this is deployed, then we will do a sequential rollout of the BusyBox application, okay? And we will put a constraint saying this BusyBox depends on this particular CSI PowerScale, because unless your CSI drivers are available and storage class is deployed, you won't have the ability to create a persistent volume and an application pod which uses that. So in order to create a dependency and a sequential pipeline, we can, and I'll show it to you how we create those constraints here actually. But these are the two files which are the entry point for the Flux to say that, okay, something has changed and something needs to be deployed. What needs to be deployed is basically, one is the CSI PowerScale components, which is stored under infrastructure in the same repo, but outside of this clusters directory, I have infrastructure under that CSI PowerScale. And you can see the files under that, starting with the namespace. So I could have made one big file out of it, but then, it's always good to kind of, segregate them so that it's easily interpreted. So you have the namespace file. Once you get the namespace in, then you basically create copy the encrypted PowerScale threads that we just saw, that we encrypted, not the private key as such, but the encrypted value of the base 64 encoded value of the PowerScale credentials. Then you have basically, I'm using a self-signed certificate, so I just need to create one empty certs here. That's the file, and we'll look into it. Now, these are the two important inclusions that we have to have. The CSI PowerScale git repo.yaml. So it references basically from where do I fetch these Helm charts. So we are looking at the Dell -Helm -charts repo, which is the second repo, and we will populate in this a resource of the kind Git repository. So it's just to say that, this is a Git repo. I've just named the file accordingly. And the second file is CSI PowerScale Helm release, which says that inside of this repo, which is the branch and where the path is for the Helm charts, because we have so many Helm charts, right? So we want to target the CSI Isilon or AKA PowerScale. So we will call that. And then you can also use some of the values overrides, which you typically do in a Helm, right? So we can do that. We will see that as well. So with these, the last one is basically the storage class, right? And then you have a customization.yaml, which actually references or sequentially addresses all these actually, right? Likewise, there's another directory under the GitOps demo, but outside of clusters, called as apps, BusyBox, and then the persistent volume YAML, and then the actual pod of BusyBox, and then a customization controller or a customization file. Now, how do we do that? You can do it in whichever ways you want. for me, what I'm doing is basically just cloning the GitOps demo, the Flux repository, okay, locally. And then inside of that, I'm creating the apps busybox and the CSI PowerScale, these two infrastructure CSI PowerScale, these two subdirectories. Navigating to the infra CSI PowerScale, since we already have the file of the encrypted file, I'm just copying it under this. And then after that, I'm starting to kind of, create the new files, the namespace, then the secret, empty secret. So this is basically just to, for the self-signed certificates. Then this is the CSI PowerScale Git repo, where the Helm chart should be downloaded from. This is the Git repository, the resources of the kind Git repository, and the URL for that. So the URL for that is basically, you can see from the variables that it will point to the GitLab and our Helm charts repository that we created or locally cloned and uploaded, committed to the upstream called as Dell Helm chart. And the branch for that is Dell Helm charts 2.10.0. And inside that, because we have so many subdirectories and all that, we are including only the path, which is charts/CSI isolon. Okay, this is where our Helm charts are. Let's just quickly do a quick look and hopefully you will get it. So Dell Helm charts, this is the URL, Dell Helm charts, and then the branch. Okay, and then inside of that, charts, CSI isolon, and then these are the charts related to CSI isolon. So this is what we are doing here, defining the Git repo. Then acting upon this Git repo, nothing will happen. If you just create a Git repo, the Helm charts won't be automatically downloaded per se. You have to create another resource called as Helm release. Okay, so once you start defining the Helm release, it will reference this Git repo. So we are defining the Helm release, let's say calling it isolon, namespace is Flux system, and then the chart spec actually says, where is this chart role located? Under charts isolon, CSI isolon. And the source ref is basically the Git repository, CSI PowerScale, which is this particular resource that we just created here, right? So this particular referencing is to the resource that we created here. This is a Helm release resource. This is a Git repository resource. So, and then, like I said, we can do through the Helm release, you can do a typical action of, overriding the, values and things like that. Okay. So once this is done, then we progress to creating the file for our storage class. Okay, this is a standard, storage class definition. You can look up on how storage classes are defined for PowerScale platform and all that. And lastly, the customization file to include all of these resources that we just created, basically, right? So this is still, all these files are locally being built onto the admin machine, and later we will actually commit them to the upstream. So then we navigate back to our apps busybox, and then we create the busybox RWX PVC. Like I said, it will reference the storage class of PowerScale, and the access mode will be read write many. Okay, and that enables the file sharing. Then the busybox actual deployment, which is the busybox pod, and inside of that we are actually mounting /mnt1 onto this persistent volume that will be created here, right? And likewise, the customization file for that, which will reference these two files. So this is basically done. And then after that, we navigate back to our clusters directory under the cluster name. Now, this is where the trigger point is, right? Because once even if you commit these above files, nothing will happen. Flux won't do anything about it unless you deposit something under the clusters, which then starts getting, or starts triggering actions, because that's a tracked directory. Okay. So we create these two customization. So you can see that the API version is customized toolkit Flux CD IOV1. The kind is customization. And the name I'm giving this customization controller is CSI PowerScale. Okay. And what it is doing is basically traversing the path, local path again, in not the local path as in the path is dot infrastructure and CSI PowerScale. And it will fetch this particular or act upon the source ref Git repository Flux system. Note that this Flux system, if I now look at what is currently present in our cluster, okay, kubectl get git repository -a. So you can see that there is just one Git repository. It's called as Flux system. This is a little misleading. I mean, could have been better. It should have been named after the actual repo name, but this is what Flux does. It just creates a default called as Flux-system. And this is the URL for that, right? Our GitOps demo Git. Okay. So this is the Git repository. And what we are doing is basically creating under the cluster name a customization resource saying that, from this particular Git repository, which is of the name Flux-system, you please traverse the path where all the resource definitions are there, /infrastructure CSI PowerScale, right? And inside of that, you have all the namespace, the storage class, the Helm release, the Git repository, and everything else basically, that we defined there. So once you deploy this particular thing, all those resources will start getting deployed. The Helm chart of including the Helm chart for the CSI drivers of PowerScale. But for the CSI drivers to work, the secrets which are stored there are in encrypted status. Okay, so to decrypt that, it provides a decryption mechanism saying that the provider is SOPs. And this is the secret, the private key that we had created as a secret in the Flux namespace, right? So the SOPs age. So this will give you an end-to-end deployment of your, a successful deployment of your CSI drivers for PowerScale. Now, once the CSI drivers are installed, then we have another customization that we need to deploy for BusyBox. And the reason we are deploying it differently and not a part of the same customization is because that we have created a constraint here saying depends on CSI PowerScale. So this depends on references this particular customization controller with the name CSI PowerScale. So unless this is met, this won't start rolling. Okay. Now this is practically about it. I know that there are a lot of files that but if you have worked with Flux, this is pretty much standard. So all I'm doing here is to actually, trying to kind of correlate how in practical, this should be deployed for CSI PowerScale. From a deployment standpoint, this will take like 2 minutes, right? 2 or 3 minutes, let's say. Then we basically navigate to our top directory for the repo and we commit these files to our, so we build these files locally, we'll do that, and we will commit these onto the GitOps repo. The moment we commit this, Flux will start actioning, the changes actually. So let's do this starting with, so we have done till here. So let's do this. We will take this whole thing. I'm just going to go ahead and, copy paste this. And sometimes, these copy paste, I might have done this somewhere else. If it results into an error, please don't, kill me for that. But let's just hope that this works. Okay, so I'm taking the whole bit here, taking it from here. Let's observe that, again, I want to make sure that we know that as of now, our GitOps demo does not have any of those apps and infrastructure, right? And inside of this, there is nothing as a customization controller, right? Nothing there. So we will go ahead and do this. Okay. Okay. So it's pretty quick, actually. If you have structured, if you have invested the time in building your YAMLs correctly and all that, it's pretty much it. Now, if you look at kubectl get customization minus A, you can see that with the age of 18 seconds, which means it was pretty quick actually, and it depends upon there's a scan interval that Flux does, but this was pretty quick, right? Sometimes there may be a lag in terms of the next scan interval and all that, but with the age of 18 seconds, this CSI PowerScale has been deployed, the customization controller, and as a result of that, but you can see that this is false because this dependency is not met yet. Okay. And you in the dependency, we have not specified any further constraints, but you can actually create different sorts of health checks based on what you want to do. For example, you want to a pod to be in a ready status and you want something to be done. So there is more elaborated way of providing that depends on constraint. We have used a simple way to reflect it. kubectl get namespaces. We should see the namespace here, CSI PowerScale, and this is with the 75 seconds, right? So this just got created as a part of the, and let's look at the kubectl get secret minus NCSI PowerScale. The secret should also have been populated. You can see that the empty certs and the creds both are populated. And the reason they are populated is because the decryption should have followed. Otherwise, if the decryption was not done properly, these creds would not be, or these secrets could not be created actually, right? Which means that now, as a result of this, if we look at the pods, CSI PowerScale, so you can see that with the age of 119 seconds, all your CSI driver pods, namely the controller pods, we have two worker nodes, so two controller pods, and you have two node driver pods basically running. Okay. Again, if any of this was your configuration was an error or something like that, all this would go into an error state. Okay. So the reason that this is running is basically a successful deployment of the CSI drivers. So the CSI drivers are installed. We should also have the storage class. So we can see that the storage class PowerScale, which is actually the provisioner is CSI-isilon delhienc.com. And as a result of this, now, if some time has elapsed, if we look at customization minus A, you can see that the BusyBox customization controller is also now saying true, ready status is true. So this is good, which means that if I say kubectl get PVC, we can see the persistent volume also has been created. Okay, it's already bound to this particular volume name, and it is using the storage class PowerScale, which in turn, this is the storage class and is using the Dell EMC CSI Isilon drivers. Okay, so this is good actually. This is a 2 minute 43 seconds. Okay, and as a result of that, kubectl get pods. So we can see that two pods for BusyBox are running. If this PVC was in error, these BusyBox also would be in error because we are mounting the directory /mnt1 to the, to this particular persistent volume, right? So this is a end-to-end. I mean, I did take time to explain you the nuances, but from a deployment standpoint, you saw that this was a brief 2-minute deployment. If you got your file structured nicely, the moment you committed to a GitOps enabled cluster in the way it's expected, practically this is about it. You can have now, while we are talking about a simple BusyBox deployment, I've used these basically ways of deploying GitOps pipelines with CSI drivers to enable, LLM models and, many GenAI applications, which at the time of serving, needs access to, a read-write many kind of RWX kind of PVC volumes with CSI PowerScale. And those are pretty powerful use cases, but can be easily kind of extrapolated that, you have a BusyBox pod, which also uses a RWX volume, right? So hopefully, this entire video demonstration gave you an insight into how simple it can be to actually align your infrastructure deployments, specifically for Dell CSI drivers. And hopefully we'll do a similar video for other Dell platforms as well. But more importantly for PowerScale, how easy it is actually to do this, and also as a part of the pipeline you deploy your applications, right? So that's about it. Thank you. I hope you enjoyed the video. Thank you.